Alright, in class today after your quiz, what you all will be looking at is writing proofs about geometry statements. We've done that with algebra so far, and we saw that it was pretty straightforward as long as we knew which property to use. We were kind of just solving equations. With geometry, it's a little bit different just because there are a lot of different directions you can go, and so it takes some getting used to. The one thing that we're going to use a bunch is this thing called the segment addition postulate. We've already used it before, we just called it betweenness, but the basic idea is anytime you have a point between two other points, we know that the smaller lengths are going to add to the larger one. And so anytime you write out an equation, like this one right here, or use some version of that, you can use that in your proof, and your reasoning is going to be segment addition postulate. So here's one quick example we can take a look at that's pretty much already filled out for us. We want to fill in those blanks, so just like we know with every proof, our first statement is always the given statement. So we're going to say PQ congruent to RS, QS congruent to ST, and that's given. Now whenever we go from congruent to equal, that's our definition of congruence we saw last time. And now in this step right here, they're taking that whole segment PS and they're writing it as a sum, or I should say the whole segment length, written as a sum of the smaller lengths. That right there is our segment addition postulate. Same with this RT, they're taking this whole thing and writing it as the sum of those smaller parts. So we're going to say Seg Add Post for segment addition postulate. You're more than welcome to use the same abbreviation. Now, here's where things can get kind of tricky, because you can go in lots of different directions. The end goal is we want segment PS to be congruent to segment RT. Another way to say that is if I can say that these lengths are equal, I could say definition of congruence to say that they're congruent. So this step right here, I'm hoping that I can get like PS equals RT. And so what I'm going to do is pick my favorite one up here. It doesn't matter which one, either PS or RT. And I'm going to rewrite it in terms of its parts, because I know that PQ is the same as RS, and QS is the same as ST. So I'll pick PS just because it's first. You can pick either one, but you only want to pick one. You do not want to do this to both of them. So I'm going to take PS, and I'm going to replace PQ with RS, because PS equals PQ plus QS, so if PQ is the same as RS, I can swap that out. I'm going to do the same thing with QS. Anytime I take something out and put something in its place of equal value, that's that substitution property. So really all I did was I took this equation and I replaced different parts in that equation with things of equal value. Now if I take a look at the right hand side of this equation and the right hand side of this one, RS plus ST, RS plus ST. Well, if those are the same, that equals RT and that equals PS. PS and RT have to be the same. And I would actually call this thing the transitive property. So we're going to see that substitution and transitive often can kind of be the same thing. We'll talk more about this later, but sometimes you can use one or the other. And again, the whole idea is they both equal the same thing, and so therefore they have to equal each other. Now I have that equation I wanted, PS equals RT. So I can use that definition of congruence to say, well, then the segments are congruent to each other. Alright, so moving along here. Here we have one that isn't filled out at all. We have to kind of get creative. This is where we're going to see how many different directions these proofs can go. I know that PQ and RS are congruent, so before I even do anything in this problem, I'm going to go ahead and put those little tick marks on there. And what they want me to do is show that PR has the same length as QS. So this whole thing is supposed to be the same as that whole thing. Alright, I'm going to go ahead and just copy down my given. Notice that they don't say anything about congruence here, they just say equal lengths. So we don't have to worry about that whole definition of congruent going back and forth between equation and congruence. So that's my given statement. Now, one thing I'm going to do is I want to show that PR and QS are the same. So I'm going to write out what PR and QS are. So PR If I look at that whole length, that's the same as PQ and QR. And that's by that segment addition postulate. I'm going to kind of divide these steps. Another thing I can say is something about QS. In this same step, I'm also going to use that segment addition postulate. I'm going to say RS plus QR. Doesn't matter which order you write that. You can add this to this or this to that. Doesn't matter. Whenever you add, you get the same results. So that's also because of that segment addition postulate. Now I'm going to pick my favorite one. It doesn't matter which one. I don't know, how about PR, because it's first. And I'm going to take out PQ and put RS in its place. So I'm going to do a fancy substitution here. And I get RS plus QR by substitution. Okay, so now if I take a look at PR and QS, the right hand sides are equal, and so therefore the left hand sides have to be equal. Anytime two things equal the same thing, they have to equal each other. So PR equals QS by the transitive property. Now you could have done this another way, where you add, so take this equation at the beginning, and you use your addition property by adding QR on both sides. That would have been totally fine. You still need this step at some point though. You need to define the parts of PR and QS in order to tie them together here. So again, always think of these proofs as each step has to cause the next one. Or you could restate that as any step you have has to be caused by any of the previous steps. You can't just put in steps arbitrarily or because you want to or at random. You got to put in steps that make sense logically based on what you already have. Okay, let's work one more and then I'll stop there and post another one here in a little bit. Here it's basically going to be kind of the same problem here, where I'm trying to prove that this whole length and this whole length are the same. In other words, those segments are congruent. So I'll start with my given. And in order to use that segment addition, I need an equation. So to have equations, I switch to equals lengths. So that's by that definition of congruence. Now I want to take a look at this whole segment, what it equals, its whole length, AB. So AB, I'm going to break it down into its parts. That's AD plus DB. Likewise for CB. Anytime you take a whole length and you break it down into the smaller parts that add to it, that is using your segment addition postulate. And since this is the same reason, I can kind of include that all in one step. And we're going to use that same trick. We're going to pick one of them. You don't want to pick both. You just want to pick one and swap some of its parts out. So I want to show that these left sides are equal to each other. That's kind of the end goal there. In order to do that, I want to kind of toy around with the right hand sides, or swap out parts to where the right hand sides are equal. So I'm going to take AB. You can do it with CB. I'll take AB. I'm going to take out AD and put in CE. I'm going to take out DB and put in EB, and we're going to see that the right sides are going to be equal. So by a substitution, AB is the same as CE plus EB. Alright, now that I did that substitution, the right hand sides of these equations are equal, so therefore the left hand sides have to be. By that transitive property. Now you might be really tempted to say, awesome, I'm done. Well, not quite. I wanted us to prove congruence of segments. So we showed the lengths are equal. The last step, we've got to say segment congruent to segment by definition of congruence.